Good afternoon, and welcome to this Progress Report number 2 presentation. My name is Herbert Lugo, and I'm a mechanical engineer currently working for ABB. Today, we're going to be discussing my engineering management project, Molding Scrap Reduction and Reutilization. I wanted to apologize for my setting. In the background, I'm a mechanical engineer by day and musician by night. Just kidding, just kidding. So let's dive right in, okay? So just to recap for the scope of the project, our maybe has an important requirement is that had is that since in the 1990s, there's been a the process has been shown that to have a minimum of 4% scrap rate. So this translates to 100 to $200,000 in scrap costs. So the plant management challenged us to two things: to from per year 100,000, to reduce by 50 by the end of the year. So what have we done in the past month? So the data gathered team for the pieces. The first one is the setup molding operator, in which is the person that ensures that the process is running stable and measures the amount of material, virgin material that the process uses. Material handler, which is the person that provides the material to the setup and also measures or weighs um, the scrap that the process creates. So with these two data that was gathered, we can see in figure one. Let's go to figure one. We can see the current trend of our material usage. Okay, this data in figure number one is the material usage including the scrap. Okay, that's the whole process of the virgin material. So remember, the scope of the project is to use or implement regrind in our processes in order to reduce our virgin material consumption. But as you can see in figure one, is that is the trend of our processes. As you can see, it's a relatively stable process with a approximate average consumption per day of 350 pounds per day. So using this information, we extrapolated the data for a whole year, and we could estimate the of our number two, the amount of material for for 125,000 a year. Okay, that 20,000 that appears on top of the 96 is the 4% that we bought in the beginning that represents $200,000. And beside the baseline, we can see the target. Now, it's very important to mention that the target was set based on the whole material consumption, not on the finished good, as you can see, the 96, but rather on the 125,000. That's why we we see a little difference between the two graphs. But that is a good news. That is good news because that means that if we reduce the scrap completely, we exceed the expectation or the target by 18,000 pounds. Okay, so that is a good indicator that if we are able to accomplish crop reduction, we will be utilizing less without increasing the reagent that we're going to use. Okay, so that's a good indicator. That's a good project. Okay, so back to our activities. On the month of April, we also, apart from analyzing, as we mentioned before on figure number 2, the data, we also created a 7 ways matrix. And this is like a Pew matrix in which we determine using the management um, cri- critical criteria for the solutions. We we set out 7 ideas and weigh those ideas per the criteria. Okay, and the purpose for that matrix is to choose the best option available or best solution available to accomplish the project. Okay, this is a very commonly used um, method or technique in order to select um, different solutions. So the key milestones for this project, we created a raw consumption baseline, which is 100%. Right now, the current solution that is proposed is currently in the 90% because it's currently under review. Okay, so we did the matrix, and we, out of the 7 ideas or 7 solutions, we picked one, but that one solution is currently under review by the management. Okay, in the engineering management as well, the engineering managers. So for next month, what we'll be doing is creating a design of experiment, fabricating a prototype to see the functionality of the solution, and to create a control plan to sustain activities for when the prototype is finished. So, okay, so now we're going to be talking about the different risks and different roadblocks that has happened between in the last week or so. And basically it's regarding resource allocation. We we had an agreement with the management that we will be using the setup and the material handlers, which are resources that are currently used for production, and they are going to be for a limited amount of time used in our project. We also, another problem is that the tool room is currently filled with a lot of mold repairs jobs and molding maintenance. So we agreed with the management to fabricate the prototype and do everything tooling in regards to tooling with outside suppliers. So that's the solution that I proposed to the management in regarding to these roadblocks, and they took it really well. So it's currently working. So as a closing statement, let me see. Once, sorry. So as a closing statement, I just wanted to present to you this information. We are in target. We are on track to finish the project on time. And the next step is, apart from creating the control plans, is to create an estimate of the cost for the solution implementation. As a mechanical engineer, I proposed to the management that I'll be making the design so they can reduce the cost of the design, but they agreed that since I am doing the design services, they will be paying for the prototype and the tooling. and manufacturing costs. So for next month, I will be estimating those costs and to see what's the ROI, what's the return of investment for this project. Okay, so we're on schedule, we're on target, and currently we're on budget, and everything is working out as expected as of today. Okay, so if there's any questions, feel free to ask. Feel free to write, and it's been a pleasure to share with you this engineering project management um, journey. Okay, so thank you very much, and I'll see you in the next one. Bye bye.